Good morning, students. In today's lecture, we will talk about homologous series. So in this chapter, we have completed hydrocarbons, the simplest organic compounds, because these are made up of carbon and hydrogen atoms only. Hydrocarbons further classified into two types, saturated and unsaturated, based on the nature or type of bond present between carbon-carbon atom. So this was your simplest type of organic compound. Then we have other types of organic compounds also, where we have functional group present in the organic compound. Means atoms other than carbon and hydrogen are also present. Clear? We know it very well that carbon exhibits property of catenation. That is called self-linking property or self-linking tendency. Carbon can bind with other carbon atom and can form long chain. So we will obtain numerous compounds of carbon. It's simply due to property of catenation. Now, before we start homologous series, let me explain this topic by the help of an example. Suppose if we talk about alkane, you know it very well that alkane is the saturated hydrocarbon. Between carbon atoms we have single bond. And alkane follows general molecular formula of CnH2n plus 2. The first member or the simplest member requires one carbon atom. Now, if you want to have next member or the second member, then we have to attach one more carbon. If we want to have a third member, then we have to attach one more carbon. If we want to have a fourth member, we have to attach one more carbon. With this, we have to attach hydrogen atoms also, so that we can satisfy the valency of carbon atom. Now, when these members are arranged in the order of their increasing molecular mass, between the neighboring members we are having a difference of CH2 unit. Then the series that we will obtain is called homologous series. So here you have the definition: a group of members of same class of organic compound. If we are talking about alkane, then we will choose members of alkane only. If we are talking about alkene, then we will choose the members of alkene only for getting the homologous series. And if we are talking about alkyne, then we will choose the members of alkyne only to get the homologous series. So here again, a group of members of same class of organic compounds which differ from each other by CH2 unit. Whenever we want to have the next higher member, then we have to add CH2 unit to the previous member. If we add CH2 unit to the previous member, we will get the next higher member. So between the neighboring members, there is always a difference of CH2 unit. If we talk about alkane, if we talk about alkene, if we talk about alkyne, alcohol, aldehyde, ketone, carboxylic acid, or whatever, between the neighboring member, the difference is always CH2 unit. We know it very well that carbon is having atomic mass of 12. H is having atomic mass of 1. There are 2 atoms of hydrogen. So hydrogen will contribute 2 EMU and carbon will contribute 14 EMU. So 12 EMU. So 12 plus 2 total will be 14 EMU. So between the neighboring members we have a difference of 14 EMU mass. So CH2 unit difference when arranged in increasing order of molecular mass is called homologous series. Each member of homologous series is called homologue. Let us get the series. Sorry, one more point. Each member of homologous series shows similar chemical properties due to identical functional group. The chemical reactions are same. All the members which belongs to homologous series exhibit similar chemical properties. That's why they belong to same class. That's why they belong to same series. But there is a difference in mass, so their physical properties will be different. Like if we talk about CH4 and that is methane and ethane, their chemical properties will be same, but their boiling point will be different, the melting point will be different. Reason? Because they have a difference of 14 AMU mass. So physical properties are governed by molecular mass, we can say, and chemical properties are governed by the functional group. If we have members from the same class, same series, then their chemical properties or chemical reaction will be same. So here let us talk about alkane series. All the members of alkane will follow general molecular formula of CnH2n plus 2. So here is your first member CH4. The next member will be C2H6, then next member C3H8, next member C4H8 and so on. If you remove one of the member from here, then it is not called the homologous series. We have to write all the members. Between neighboring members, we have a difference of CH2 unit. CH2 unit, add 1 carbon, it becomes 2. Add 2 hydrogen, it becomes 6. So it is C2H6. Between C3H8 and C2H6, add CH2 unit. Adding 1 carbon gives you 3 carbon here. Adding 2H gives you 8H here. So between the neighboring members, there will be always a difference of CH2 unit. As CH2 unit contributes 14 AMU mass, so between the neighboring members, the mass difference will be of 14 AMU. Then we have Alkene series. All the members of alkene will follow general molecular formula of CnH2n. Here, first member C2H4. We cannot have first member on one carbon atom because we need double bond between the carbon-carbon atom. Then C3H8. Add CH2 unit here. Adding 1 carbon gives you 3 carbon here. Adding 2 hydrogen gives you 6H here. Difference of 14 AMU will be there because we have added CH2 unit. Compare next C4H8, C3H6. Add 1 more carbon, it becomes C4. Add 2H, it becomes 8. 6 plus 2, 8. Again, a difference of CH2 unit is there, or we can say difference of 14 AMU mass is there. All members will have similar chemical properties, but as there is a mass difference between the different members, so definitely physical properties will be different. Same thing is applicable for alkane series. All members follows general molecular formula of CnH2n minus 2. First member will require 2 carbon, so here is your 2 carbon member C2H2. Next member C3H4. Difference of CH2 unit is there. If 1 carbon is added here, it becomes 3. If 2 H atoms are added here, it becomes 4. So there is a difference of CH2 unit. So here is the homologous series for alkyne. Homologous series for alkyne. So this is all about homologous series. Thank you and have a good day.